Hi everyone, this is Ernest from ASAlytics team. My name is Ernest Wojori in full. For this milestone, which is the data wrangling milestone, I'll be working with Precious Kolawole, and we will be doing this presentation together. Resting on the presentation we had, where Busayo, our fellow teammates, our data and our data engineer, where he introduced how we've implemented our data engineering section. He extracted, that is by getting data from the demo that he extracted, getting data from Twitter, from Reddit, and from GitHub, and how he made data to pass through some of our pipelines and save it in the database. So for this milestone, we'll be transforming those data and be seeing some key analysis that we can bring out from those data across the data collection platform, I mean Twitter, Reddit, and GitHub. So here I have the data analysis doc. In this section, we will be presenting to you the data analysis doc and the Jupyter notebook to show our codes and demo some interesting visuals. So for this doc, the aim of this doc is to put every stakeholder on the same page such that all the technical jargons might not be necessarily comprehended. But with this doc, you get to be on the same page with whoever codes it and whoever wants to listen to the technical stuff. Yeah, so in this notebook, we prepared like some steps, like some tables to guide whoever wants to understand how we clean our data, what are the problems we face, and how did we treat them. Without wasting time, we really stated that our data analysis was from, our data collection was from Twitter, Reddit, and GitHub, and our approach towards cleaning is thus. So this table is to present the problem and how we want to approach it. After approaching the problem, what's the expectation in terms of what the data or the problem should look like after being solved? And the status is, are we done with this or is it in progress? So for the Twitter, which is my home part, and one of the first problems we had was we wanted to export the data from Cloud SQL and just munge it locally without having to connect to the SQL server directly. But we noticed that some integrity of the SID were being comprehended. What do I mean? If you export, for example, the SID column, the ID were striping out at maybe the 9th digit or so. So that's not giving us what we wanted. So we solved that problem by connecting to Cloud SQL directly, using Cloud SQL Proxy on my Linux server. And after that, I was able to produce an SID that goes in par with my expectation in terms of the data types and the structure. So another problem that we faced and we saw, and it has expected, is data that are coming from tweets are unstructured. They have a lot of unwanted characters and all. So we wrote some regex, regular expression syntax with Python, with regex library in Python, and we took care of, at first we normalized the character form, we ensure that it's normalized. Then we remove retreat URLs, white spaces, words, and any form of tag with ads and all. So Regis took care of those cases, and we have a clean text that is ready for analysis. Another problem we tried to solve was some of the ASAID column. We have a column in our database that is called ASAID that is expected to be the IDs of each respective ASAs. Some of them were coming with curly brackets, like this square bracket, and this dictionary bracket. So we try to write a simple function that replaces this all kinds of the open and the closing bracket with nothing. Yeah, so some columns like liked, retweet, and protected. Liked is expected to be an integer, retweet is expected to be an integer, and protected is expected to be a boolean. That is a true or false. When we load from the Cloud SQL, some of them are coming as an object that is a string. So we needed to correct that, and we wrote a simple function to do that. Then after all the cleaning and merging and ensuring everything comes to what we expect, we try to say, okay, a user, what ASA we want to understand one or two things about their data activities. So you get to pass in an ASA ID, then our code extracts or remove or set aside the particular data that covers for that ASA. For example, agro main just going on. Or you don't have to make your code complex by getting everything when, however, you only need to get for a particular ASA for that runtime. So that is that for the cleaning for Twitter. So as I said earlier, my colleague Precious will be talking about the Reddit and the GitHub. So I'll be moving over to just a glimpse of what types of analysis we are going to be running and explaining in detail after showing this doc. So for Twitter, we want to understand how the likes of all tweets that have been tweeted about a particular user has grown over time. What's the maximum number of likes that a particular asset has gotten as a traction, and what's the minimum and all. So we also want to understand that about the retreat. How has the retreat grown over time? What's the maximum and all? So in the same way, likes and retreats, we want to understand which day of the week or which hour of the day does particular like get to be higher than the other. When can we advise users to tweet more and all? So that was why we prepared this section of the of the visualization. We repeated the same thing for retweet, and in the same way we try to compare two entities. I mean, entity by entities I mean like likes and retweets are important indicators about Twitter activities. So what we want to understand, is there any relationship between likes and retweets? As likes increases, is retweet also increasing alongside, or is decreasing otherwise? So this graph is showing us in that vein by showing us how likes and retweets are related over time. In this case, the time to be considered is hour of the day. We did the same thing for the weekday, that is across Sunday, Monday through to Saturday. Is there any common trend or uncommon trend about the likes and retweets and all? Also, for all cases of tweets without categorizing by time, by any time index, we want to understand for all tweets that have been made by some about some ASAs, what's the number of likes over the tweet that is over the index? What's the tweet like? What can we say about that? We also try to understand what frequencies, which is best shown with a word cloud anyways. Word cloud gives you a visualization of words in terms of their frequency. The higher the frequency, the bigger the magnitude on the cloud. Like this visual now is telling me that this particular asset talks more. The keyword choice coin background is coming more compared to community, compared to token, compared to let and all. So that's just what cloud gives us at a glance. And also we try to have a sneak peek into what. So this is just the sentiment part. We try to want to understand across all text in the data or in the data per ASA was how many of the texts have been positive, how many have been neutral, how many have been negative. So I actually tried, my colleague and I tried different approaches, and it's just a way of us trying to have a sneak peek into what the sentiment looks like. So we tried TestBlob. TestBlob is a Python library that some pre-trained models have been saved there for us to try out without having to go too deep. Yeah, so that is that for a quick overview in this doc. So in the light of that, I will be showing a more detailed explanation on the notebook. This is the notebook section. This is where I imported all the libraries that I needed: NumPy for numerical Python, pandas for data frame manipulations, matplotlib for plotting. Then I try to use some style in matplotlib, try to use some effects in matplotlib. Seaborn is another visualization library that is built on matplotlib. Unicode is for me to manipulate my character form. R is regex for regular expressions. Word cloud is for me to initiate my word cloud plottings. There's TestBlob, the library that we save the pre-trained model called the class TestBlob in capital letter. Yeah, so this is me trying to read my data directly from my Cloud SQL proxy. Yeah, Cloud SQL, using my Cloud SQL proxy. I initiated the necessary classes in database, necessary tables in database into these classes. We have the Twitter table, interactions table, and the throughput street table. So Twitter table is basically what we had before, where we also have interactions. Interactions comprises of likes and retweets. We try to get the likes separately from the original tweet because we were streaming. I might not want to go into detail of that, but for this milestone, we also added historical tweets where we have almost everything we needed. So for this case, for this particular milestone, we were reading from the historical tweet table in our data. So we initiate the section, we got the necessary ID, and this is my transform class. So almost pretty much everything that I stated in the data analysis doc, where I explain every cleaning that happened for Twitter, this is where the code actually works. This is where the code starts. Yeah, this is where the code starts. Yeah, so all the processing that I did, this is just an init function, always present in all classes. Then it gets Twitter DF, getting the data from Twitter table. I've stated earlier that we are not using that for this milestone. Gets inter DF, gets data for interactions table. Then this is what we are using, the historical DF, which is getting data from the historical table where it contains almost everything we need. So my function is working that out and save it in a data frame. The data frame is what will be useful. Then this merge DF is being used to merge the initial interactions table and the Twitter table. In this case, we are not currently using that. So yeah, the clean tweet, this is where the regular expressions or cases of regular expressions that we needed to write, this is where it happens. This is normalizing your string. This is just confirming normalizing your text, confirming it's in string. Then after normalizing, I ensure that I encoded it to UTF-8. That I prefer UTF-8 to the format that I had there before. Then I wrote a simple regex to remove retweets and all, remove ads, remove URLs, remove all these word characters, then remove all these cases as well. And these are just this is white spaces. So remove white spaces and all. So this particular function takes care of almost everything about text cleaning, as far as we've seen, and it works as far as we've seen, and there has not been issued about that. So I also stated that some IDs had issues that we needed to treat. Some IDs that was reading through the ASAID column, we needed to remove all these braces because it came with the data in our database. So I wrote a function to take care of that. Fix data type. I stated earlier in the doc that the likes, the retweets needed to be in integer, protected needed to be confirmed to be in Boolean. So the choose ASA, this is where we select the type of ASA that the user wants to actually understand some insight about. So you get to, my input function is requesting for which ASA, which you get to pass in the ID. After passing the ID, this extract out the particular data that has to be with the ID and get it ready for my other classes to use it for analysis. So this all is pretty much implementing everything about the other methods. What I mean by method, all the functions that I've written earlier in sequential order, so that it will give me a desired result, which is my DF final in this case. So if I make use of the transform class for this particular use case, choice coin, if I run this, it will ask me to pass in my ASA that I want to analyze, and I pass in the particular choice coin ASA ID, and it extracts the particular data that is needed to run the analysis and saves it in DF underscore, save it in the data frame. I repeated pretty much the same step for algo mint, repeated the same thing for usually, repeated the same thing for social, and that works. And as you could see here, this is the shape of each of those ASAs respectively. We have 5 to 8 for choice coin for algo mint, for usually for social, 4,780, 14268, and 638 respectively. So this is where I get some interesting insights from my likes class. Like is like a particular entity which my other class retweet actually inherited from it. So pretty much what like does is every single analysis that I needed to do that has to do with plotting that is not text-based, all kinds of trend, all kind of line graph and plot and all. This is where it happens. So for the first method that I have here, day of the week, this pretty much extracts the day of a particular week from a date-time data. I pass through a date-time data. Yeah, I have to let my class know this is where my date-time column is. So given that, I got to extract the day of the week from it. When you extract the day of the week, it does not come as Sunday, Monday, or it comes as integers. So for this case, I notice it's 0 through to 6, which are renamed within the dictionary and all. and everything went well. So from this, I also did the same thing for the hour of the day, pretty much updated my data frame with the hour of the day column, just like I did for the day of the week. Then this plot line, this is the function that plots all cases of line graph, and it takes in what the x-axis is, what the y-axis is, and what you tie to it, and this is the real data that I'll be plotting. Plot bar pretty much does the same thing like plot line, but just plotting a line graph. Compare bar, this is if I want to compare two particular bars, just like I did. I'm going to be showing that down there. I showed a glimpse of that in data analysis doc. These are just formatting of all kinds. Compare line, pretty much the same thing as compare bar, but for lines. So if I want to compare two lines, I got to use this function and all. So group by, almost in all cases, I always add reasons to group by a particular categorical data, then try to see across those categorical data, how has been the frequency of the interested variable is, which is always a numeric number like like and retweets. So whenever I needed to do that, I make use of this group function. And in my plot, this is where I wrote all the logic that takes care of which type of plot to show for which condition. So I have the parameter of weekday and time of the day. So if I want to understand insight about the weekday, I say weekday equals true. Then I get to see plots that suits weekday. If I want to understand for time of the day, I say time of the day equals true. Then I get to understand plot that suits time of the day. It also has another 2 levels of conditions, which I'm going to be explaining in more detail as well. However, if you pass the two to be true, it will not give you any plot because the condition does not take care of both cases. So that's important to note. So if weekday is Sunday through to Saturday. So I called my method day of the week method, which updates my data frame with day of the week column. So then if entity 2, in my class function here, I have a parameter that asks if you want to compare another entity with the original entity that you wanted to see the insight. So if you are comparing this, that is when, so if weekday and you have an entity 2 that is not an empty string, that is when if it's not equal, the length is not equal to 0, then do the comparison plot. Get the group for the one, get the group for the second one, then compare the plot. Else, that is if you are not comparing. This is the cases when you are comparing. If you are not comparing, do this, which is plotting the single entity one, that is the single entity that you had there, which could be like or retweet in both cases. Then the two conditions have been met. So for the other one, if time of the day, and also even though it's time of the day, if you are trying to compare, which means the length of the entity 2 is not an empty string, then pretty much get extract the data for the first entity, extract data for the second entity, then compare their plots. Every of this will be shown with graphs, and everybody will see that loud clearly. So if we are not comparing, pretty much show me a plot for a single entity. However, if you are not considering either of weekday nor time of the day, you just want to understand how the lights have gone across each tweet. So you get to use this. Then, even though you want to understand across each tweet, there's still option for you to compare across each tweet. So if you are comparing across each tweet, then pretty much this happens. You initiate the first entity, initiate the second entity, then you compare it here. Then if you are not comparing, then pretty much plot a single line for the first entity. Yeah, so that's it. Then the class for the text pretty much has two main objects, which is the word cloud and the sentiment. This class performs all kind of analytics that we are currently considering for the text column, that is the tweet itself. So there are two things that we are considering here: the word cloud. This function does that. I might not need to go into the technical detail. I don't think that's necessary. This function does that, and it gives me a visual of what the word cloud looks like. Then the sentiment, this function gets the sentiment score, categorizes it into 1, 0, and -1, which is positive, neutral, and negative respectively. Then update it into my DF as sentiment score column. Then given that sentiment score column, use this function to give me a graph that shows their magnitude across positive, negative, and neutral. So a demo, that is what I will be doing. I will just be doing just for one ASA. The rest is pretty much a repetition that anyone can read and understand what has happened. So for choice coin, this is, I'll still come back to this inside Hydra. This is me trying to initialize the like class and passing the entity one to be like, and the date time column, the column that contains the date time data is date. So I've initiated that. I'm not comparing anything. Please note, there is no compare with, so which means I just want to show what entity. So time of the day is true. If time of the day is true, it's showing me this. Then if weekday is true, it's showing me this. If I did not specify any, either of time of the day or weekday, then showing me all the graphs across all possible tweets. The same thing for retweet. Retweet has generated from like class, so I don't need to initialize any method and not just generating from it. So this is retweet, and the entity one is retweet. The date is just like we have it in light. They're all pretty much the same thing is happening here. I'm showing the retweets, showing the retweet for per hour, showing the retweet per week, per day of the week, then retweet for all cases of tweet without categorizing by any time attribute. So now if I want to compare, I have my entity one to be likes, my date column to be this, and compare with retweets. So if I'm passing this and I say, okay, time of the day is this, so the same function that we got in time of the day, but with a single entity, then we now get to compare with two entities and we could see whether they follow the same pattern or not. Then for the same thing for weekday, see it for two entities and see how they relate to each other. The same thing for cases where you are not interested in categorizing by any of all those time variables. So from the insight I could, okay, let me get to the sentiment part. This is pretty much the word cloud. I believe this is obvious. I believe this is obvious. And then we have the sentiment. This is showing that we have a lot of positive, also some neutral, but there are very few negative, which I believe is also you need to pay attention to. Why do we have negative? Why are people treating negative stuff about this particular ASA? That's that for choice coin. Then looking closely from my hand, I could draw this insight that from the graph, it can be seen that tweet made on the 10th hour of the day have the highest likes, followed by the 17th hour, that is, and on the contrary, the third and the 19th hour have low likes. Then for the day of the week, Saturday, Tuesday, and Sunday have high likes. By Thursday have the minimum likes. The maximum likes for the particular data range that we got was 300, a little bit above 300 likes, and there's a pattern in the trend actually. Retweet pretty much follow the same trend as likes, and the sentiment, they are high positive, few negative, and medium neutral. So almost the same thing happens to the different ASAs that I had shown earlier that we wanted to plot their graphs. So I might not want to go into each detail because it's going to be like I'm doing a tutorial. It's going to be like a tautology, like a repetition for almost the same thing that I've said earlier. So the insights are there, pretty much interesting and all. So I'll be handing over to my colleague now for the other part of the presentation.
Awesome. Okay. All right. So hi, everyone. I'm Precious Kolawole. I'm the data scientist on the ASAlytics team. Like my colleague has said, I'll be taking us through the Reddit and the GitHub data preprocessing analysis. All right. And since the data analysis is one of the crucial steps in data preprocessing is one of the crucial steps in data visualization, all right, and also from any script data. So I'll be taking us through that of Reddit now. When we script the Reddit data in from our database, we encountered some problems which were solved, and we had the final results. So I'll be taking us through the first one now, which is like the problem of exported data labels not properly labeled. Since our Reddit data has both the post table and the comment table, some of the columns, some of the data labels in the post and comment tables, they are not unique. They are not unique. So we had to use Python in altering the axis labels using the pandas rename module in Python. And then after doing this, we have a result which contains a new data with unique labels, properly labeled and assigned, properly assigned to the label, sorry. And then the next problem we faced is the fact that we had non-correlating parent ID in the comment table with trailing T3 underscore preface. That is, the post table and the comment table, they both have parent IDs. But unfortunately, after we got this data from our DB, the comment table happened to be having trailing T3 underscore before the parent ID. So we had to solve this problem for us to have uniqueness across all the parent ID by using Python functions to cut a way to cut across and stripe out all the preface. And after this, we now have a comment and post tables with matching parent IDs. All right, the next problem we encountered in this sense is post title and text containing URLs and special character. Let's say a user drops a comment under a post and then is referring somebody to a URL in it. So those posts, those tests, they happen to contain URLs, HTTPS or HTTP URLs. So we had to solve this, not only URLs alone, special characters like underscore, like hash, like @ and many more. So we solve this by writing a data structures function that removes the URL and takes out accompanying characters or even emojis from the text, from all tests. And then the final result is we having post titles and text bodies containing only English alphabet and not special characters or URL. So the next problem we faced here is data dates appearing to be in Unix format and not in the normal standard or the general standard time, which is known as UTC. So we solved this problem by converting all datetime labels using the datetime function in Python to convert all these Unix or Unix date related columns to UTC. And then after this, we have a data containing datetime columns represented in UTC and not Unix. All right, so the next problem we faced is numerical colon appearing as strings and not integers, or columns like, let's say, upvotes or appearing in strings instead of integers. So we had to solve this problem by converting the data type. And then we use pandas modules, which is very, very flexible in solving different data problems to convert this data type into the appropriate format. And after we did this, we have our data returned, or our data label returned in its proper types. And then the next problem is extraction of particular ASA to analyze per time. That is, at times a user wants to just analyze for just an ASA alone and not for everything. Our application is like is flexible enough to allow a user to input the kind of data, like the kind of assets they want to analyze at that time. We wrote a function to perform this analysis to request for an input from a user, and then it returns a data frame containing that selected ASA alone. All right. Oh, talking about ASA, I mean, yes, Algorand standard assets. So the next problem we faced, which happened to be the last one, is flexibility to select date range to analyze per time. Let's say a user just wants to like visualize or analyze from just, let's say, December last year, 2021 to January 2022. And then the entire data happens to start from, let's say, January 2022 and January 2021 and January 22. So this application allows a user to flexibly input the kind of date, the date range they want to analyze on. And then we created a plot that permits input from a user, that is the start and the end date. And then we have our algorithm returning plots in that particular specified date range. All right, having said this, I'll be moving on to the ASAlytics Reddit data preprocessing notebook. All right, so here is the Reddit data preprocessing notebook for ASAlytics, which is like me talking about the code aspects of everything which has been in the data analysis talk. Here we used Python and pandas, like I said earlier. NumPy allows you to work with linear algebra or mathematics computation with data. And we have pandas, which is very, very great in data processing, like loading, extracting, renaming, striping, and all of those. So we used both NumPy and pandas as our first libraries. And then we used Regex in striping out the HTTP URLs, like I mentioned earlier. We used random for generating random numbers, or in our data. We use datetime function, which is like a class necessary for manipulating dates and time variables. Then we have this Vada sentiment, which allows us to, it's an AI model that allows you to generate sentiment score from any test data passed to it. In my analysis, I used Plotline, which is an interactive graphing library built on Python. This Plotline is actually a high-level interface or graphing libraries with different functionalities, with different functions. It allows you to make them interactive in such a way that you can see the trend while scrolling, while hovering on the plot. All right, so we imported different functions from the Plotline libraries, and then we imported word cloud as well, which is like a function, not a function in this sense. Word cloud is like a library that visualizes frequent words in any text, showing them in sizes of their importance, of their frequencies. All right, so we use Seaborn. It's also a visualization libraries in Python, and also Matplotlib for some of the plots which are not done with Plotline. All right, so moving forward, we imported our data, which has been scraped from our database, and the two data, like I mentioned, the post data and also the comments data. Here we are trying to instantiate the sentiment analysis model, which is used in understanding the feelings and getting the sentiment score. And then the next line, which is line 5, we tried getting the number of assets in our data. And then we can see we have AlgoFi, we have AlgoGems, ChoiceCoin, AlgoMint, ZoneGameFi, Social Official, and those are the ones we are working on right now. Also, so we have AlgoFi, AlgoGems, ChoiceCoin, AlgoMint, ZoneGameFi, and Social Official, and those are the ones we are working on as regards this demo. So I'll move on to the Reddit analysis. How I've been able to analyze all the data in our Reddit table. So here, this is the Reddit analysis class, which is like a preliminary class to pre-process all this Reddit data and prepare them for further analysis. And then this init function is a special method in Python, OOP, which automatically get called anytime any object in this class has been created. And then it takes in the data, the data to be analyzed. All right, so moving forward, we have a function called rename post colon. The rename post colon is the function that takes in the post table, the post data table, and then it iterates through the post table so as to generate unique names for each of the data label, so as to solve the problem of inconsistency I mentioned while explaining the data analysis talk. So here we actually worked on them, dropped some unnecessary data labels while renaming them using this code. All right, so let's move on. We did the same thing for the comments table because it also has some inconsistency problem. So we did the same thing, and then we move on to striping the comments ID preface problem of T3, T1. So this function takes in the comments table because the non-correlation is on the comments table and not on the post table. So the focus here, the aim here is to make the comments table preface ID the same, correlate with the parent or with the post parent ID table. All right. So moving on we had to merge the two data frames, the two tables together, so as to turn them to one and perform necessary analysis. And then we merged them on the parent ID, which has been previously worked on while creating an inner join on them. So the next part is we removing the URLs, the HTTP and HTTPS URL. And we had to use regex in this sense, regex, sorry. I mentioned it during the library importation. We used regex in taking out all unnecessary HTTP and HTTPS URLs from our data. And then the next part is we're removing the special characters in our data. And we used mainly Python for data structures process in taking out all the special characters like underscore, like hash, and all of those things. And then after taking them, after running through the entire test data, we separate them and join them back to the way they've been imported. All right. And this special character function only takes in the test and not the entire data table. So we have another function here which takes in the data table so as to access the special character remover function in our Reddit analysis class. All right. So this runs through a list of, because I said list here because we have both the post body and the comment body with special characters. So we had to take them together and perform the analysis at once. So we implemented the access SCR function to get this done for the two or even many data columns with special characters. So the next part is the function carrying out the units to UTC function as explained in the data analysis talk. This also automatically takes in a list of a data column with Unix, like the date columns with Unix, and then it runs through each of them, check if they are in UTC or not, or UTC or Unix. If the thing is in Unix, it automatically converts to UTC. And if the thing is in UTC, it leaves it the way it is. All right, so we move on to the part of we extracting the necessary date-related components from our data. This also takes in a list of date columns because in our data, we have like two different columns, labels with date values, datetime values. So it automatically takes in the two or date columns at once, extract the necessary date-related components like year, day, month, hour, and the day name, which is like weekday from this data. And the last part is we generating the sentiment from our data. This in this part, I said we used VADA, or in this sense, an AI model that gets this done. So we passed the data, like the post body, the comment body containing tests, we pass them to our VADA model. And after doing this, the VADA model gets the negative score, the positive score, and the neutral score for each of them. After doing this, it gets the compiled, the point count, like the mean of all the predictions, which is called compound in this sense, like this compound variable. So we get this assigned to a variable name called post score and comment score. So after doing this, we zip the two post score and comment score, automatically convert them, checking out some conditions, like if one is greater than 0, turn it to positive. If someone is less than, if the score is less than 0, turn it to negative. And if else this, make it neutral. So after getting all the scores, we appended everything to our data frame, and the data frame gets returned after. So the next function here, still talking about the analysis, is the part of we working on the type of the data our model has taken in. Here we are working on the comment upvotes, which is coming in as string from our database and not as integer. So we performed a necessary analysis in converting that data type back to int, because it will be mostly, it is best assessed when it is an integer. So the all function here takes in the entire function in our Reddit analysis class, access each of them with the respective or input with the respective data entity they require. And after getting all of this, once all these conditions are true, once all these conditions are coming out positive, it returns the data frame back in its clean format. So this line 7 of our data is assessing this dot all function from our Reddit analysis class so as to perform every analysis, so as to instantiate it. So once this is done, we have our data cleaned, ready for analysis. The next part is we choosing the kind of assets we want to work on, we want to visualize. Like I said, it is flexible so that users can tell us, okay, this is the kind of asset I want to get insights on. So this function is doing that. And the next one, which is like my cell 9, sorry, in this sense, is assigning different asset name to is assigning like different asset data to a variable name. Like AlgoFi now is assigning AlgoFi to AlgoFi data variable. Choice coin is getting added to choice data variable, AlgoGems data, and like that to AlgoMint. So now, since our data is ready for analysis, and we also have all the data segmented into different sections. So we need to start our visualization now. So we have a class performing the visualization, which is called Reddit plot. And this plot is using the plotline library I mentioned, which is very interactive, so as to get all the graphical representations of our data and generate insights accordingly. So we also instantiate an init class, which takes in the data and the label to be worked on, and it is accessed anytime the Reddit plot class is created. So we have a data variable and then entity variable. Data in the sense that the kind of data we want to work on, and entity in the sense that the data column we want to analyze. Now we have our date selector function inside our Reddit plots. It allows a user to select the date range on which the analysis will be done. It's answering the question like an inquiry. Would you like to select a date range? If yes, then it will tell the user to input the time, the start time. What that has been inputted in this particular format, then it asks for the end time to the end date. And once the user has dropped that, it returns the input of the user. And if the user is not saying yes, if the user is trying to get insight from the first day from the first date to the last date in our data, it is going to do that flexibly. So we have a function called plotbar, and this plotbar function is getting instantiated for all the other visuals at the bottom. That is, we can decide to plot a bar chart for our visuals, and we can also decide to plot another visual, like another plot style for our data, which the one we used in this case is scatter plot, which is also called line plots, the way it is sent. All right, so our bar chart is taking in the x-axis, the y-axis, the text to be displayed on the output of our visual, and the time at which the analysis will be done. So this is like a baseline function in all necessary components, and it returns the chart for all the other functions which will be discussed below. So in this part, we specify the ASA name, the kind of ASA the user is trying to get for it to be displayed on the plot. And then we have trace. Plotline library for our visualization is leveraging on a word called trace. It can be another name really, but in this case, we have to stick with trace because it allows you to trace in different data columns with a different section. So we have the go.bar, which is accessing the bar chart itself. And then it is taking in the necessary components. We specify the kind of color we want for our analysis and the width, that is the kind of space the visual can contain. And then we specify the text also. So this next part is we talking about the layout, how we want our visuals to be seen. So the layout is taking in the kind of bar mode we want. It can be stack, it can be group, that is stack on top of one another, group side by side. And then we specify the title or the title of our plots, the title, the general title in the sense, and then the x-axis showing the title of our x-axis, the y-axis showing the title of our y-axis, and annotation talking about the size of the text displayed on our plot and many other things. So moving down, we have This is us just updating the layout so it will fit different requirements. So we have the same thing which has been done for bar, for the plot bar, also done for the scattered design, for the scattered plot. All right. So this one is taking in the same inputs as the plot bar, and also performing the same function. The only difference is that the previous one is going to give us a bar plot, and this other one is going to give us a scatter or a line plot. All right. So let's move on so as to be time conscious. All right. So this is the next function, check upvote, which is checking if we are trying to analyze our data in days, in hours, or in months. It invokes the plot bar or the scatter plot or the plot scatter function I mentioned, I explained earlier, and then shows the trend at which the Reddit posts and Reddit comments of a specified asset are being upvoted per time. That is, we are working on the way upvote is influencing what is being said about a particular asset. So we created this. If a user is specifying day as true, it works on this algorithm gets to run, and then it accesses the plot scatter function at the top while taking in the necessary parameters. That is what should be in the x-axis, what should be in the y-axis, what the text should contain, and the kind of value, which is day mentioned there. So it does the same thing for when a user is dropping hour, when a user is trying to check for hours, that is when hour is true. Also when month is true, on and on like that. The first one for days is scatter. The second one, hour and month, so they are also shown as scatter plots. But this last part, let's say a user is not trying to check for any day, any time, any hour, we get to show them per weekday. And that's what this next algorithm is doing. And this time for weekday, the best plot to show this is bar. It has to be in bar for it to be perfectly, for it to communicate the insights perfectly. All right, so the next visualization, the next insight we are trying to get here is most upvoted answer. Most upvoted answer gives insight to the asset with the most engagement on Reddit. And then it takes in, it is also a bar plot, and then it takes in the ASA ID, that is the name of each of these ASA, and then the entity to be analyzed. And then it gives it a title, most upvoted ASA. We set the color. And then the most fun part of this is that we have to set the color according to the range. That is, the color is continuous as depending on the scale. If let's say Choice Coin is having upvotes of about 300 and we have AlgoFi of about 1,000, the color of Choice Coin will be less thick compared to AlgoFi, because AlgoFi is having the most upvotes. The visuals, the plot will be seen once we get to the stage. All right, so the next part is we designing how our layout should look like, and then we specify templates as plotlight dark, so the background can be seen as dark. We set over, that is, anytime you click on the plot, it will show you the line from where it is coming from, either on the x-axis or on the y-axis. So the last part is we getting the word cloud design, the word cloud plot, the word cloud visual, and then we set the stop word so as to remove all the normally occurring tests in different test data, like and, the, will, normal words. So the stop word is taking care of those ones, and then we set the particular algorithm there. So this also is plotted, and then we have our sentiment plot, which takes in the post sentiment and also the comment sentiment. The post sentiment is called 1, and then the comment sentiment is called 2. So this part, we group by each of them to get a number of comments, the value count of the neutral, the positive, the negative sentiment we have. So after getting the value count of each of them, we plotted them here using bar charts also. And then this time we said the bar mode is group. You know, the other time I said the bar mode is stack. so as like stack them on top of one another. But this time we are using group bar mode so that they will be seen side by side. So this time we sorted them category descending so that the most occurring one, the one with the most occurring sentiment, like after the sentiment has been get, the most occurring one is seen at the top, and then the hierarchy goes down to the least. So we get this done and we set the layout how we want it to look like, which is majorly the same as the previous plot. So this time we go into the plot and we get to see the design course. We believe people get to understand codes better when the picture is seen. Like all humans, we get to understand pictures better than just numbers or code. So right now, this particular function, because we did a particular analysis here so as to get the most upvoted answer. And then this is not working on a single answer. It is working on, I guess my colleague has already mentioned ASA, like Algorand standard assets. All right. So we are trying to get all these assets at once and check the one with the most upvotes. So this time we had to create a new data frame containing all the assets and not just a single asset. So the first analysis we try doing here is getting the upvote trend analysis, how upvotes has been varying over time. And then we understand like user gets upvotes makes like a user is approving this particular post or in support of it. So the upvotes is something our ASAlytics is leveraging on pretty well. So the first plot here is most upvoted answer. And this helps us, like I mentioned, in giving insight to the standard Algorand asset or Algorand asset with the most upvotes. So let's check it out. Now we are trying to assess this Reddit plot, or this, we are trying to assess this most upvoted ASA function inside our Reddit plot class. All right, and then this is the output. We specify the post upvotes, and then we specified the post upvotes, that is how the posts have been upvoted. And as seen in the visual, Algo5 is seen to be the most upvoted ASA with about 43,289 upvotes in general. And then we can see Algo Gems, which is following with about 32,128 upvotes. And also we have Choice Coin, which is next, 17,198. And moving to the list is AlgoMint. AlgoMint is having about 1,538. So we have our x-axis showing the asset and the y-axis, sorry, showing the asset, and the x-axis showing the rank. All right, so let's move on to. All right, so we are trying to analyze for each of those ASA one by one as a case study. And we are taking Algo5 first. So this part, we are trying to get the trend of upvotes per day. And we have the time in day on the x-axis, and then we have the count on the y-axis. And the trend can be seen here. The 16-hour is seen as time when most upvotes are dropped. All right, so let's move on to the trend of comments upvotes per day. And this is seen as like the 21st, day of the month, sorry. I missed this part, 16th day of the month. And this one is like the 21st day of the month is like the time when most upvotes have been dropped. So the next one is trend of upvotes per hour. We did it for the post and for the comments, but this time I'll just be showing us that of the post alone. So this time we can see here the 18th hour is seen as when most upvotes are dropped. And then same thing, we have time in hour on the x-axis and the count on the y-axis. So moving on, we have the trend of upvotes from per month. For the trend of upvotes also, we can see that the 12th month, which is December, is when most Algo5 upvotes were dropped. And then, all right, so let's move on. This is also showing for the comment and still the same insight, 12th month. So we move on to the trend of upvotes per weekday. And for Algo5 again, we can see that Monday is when most upvotes are dropped. Friday is the next, and we have Thursday following. So here, we have the word cloud as explained. The word cloud is showing the frequency as at which the tests are on the posts and are on the comments. So we have AlgoFi and all of those things being displayed in the word cloud, this visual. And we did the same thing for the comment body. So right now we talk about sentiment analysis. And like I said, this is showing as in group. And then we visualize both the post sentiment and the comment sentiment on just one plot. This x-axis is showing the category and the y-axis is showing the score. So for post sentiment, we have 1082, and then for the comment sentiment is 1056. In general, we can see that most tests are positive and the lists are negative. All right, so pretty much we did the same thing which has been done for AlgoFi, I explained. We did it for AlgoGem, we did it for ChoiceCoin, we did it for AlgoMint and the rest of them. So as we are rounding up, I believe we'll get to go through the visual one by one over on them and see how the trend are being displayed. Thank you. Okay, hi everyone. We are now talking about GitHub, how the data is being cleaned since it is dirty while being scraped from our database. So the first problem we encountered is, in this case, is repository having trailing asset name. For example, we have ChoiceCoin /voting. Voting is the repo name, repository name, but ChoiceCoin is seen to be trailing, to be a prefix before the repo name. We had to work on this using Python. We had to take it out or using the stripe function in Python pandas. And then the final result is we having all the name of repositories individually returned without the asset name. The next thing we did here is, the next problem we solved here is missing date-related components. That is, we needed to extract things like day, hour, weekday, year from our data. So we had to write a Python function to extract the dates component from our dates column. And the final result is we having a data frame with additional columns of dates components added to our data frame. So the next part is extraction of particular asset to analyze per time. Like I said, our program is, our algorithm is flexible so that a user can always drop the answer they want to analyze. So we wrote a particular function to choose an answer for analysis. And then we get to return a data frame that contains the only selected asset data. All right. Now we talk about our Reddit data preprocessing notebook. The Reddit data preprocessing notebook with a link attached to our GitHub, when we started, we had to import the same data with the same libraries as Reddit, NumPy, Pandas, which I will not be explaining too much in this sense. All right, so we have other libraries imported as well. And same as Reddit, we use Plotline, the interactive graphing library, in visualizing our GitHub data as well. Nothing is different from what we imported in our Reddit and our GitHub notebook. So we get our scrape data imported and we set it as DF, our data frame name. So we move forward straight to how we were able to analyze our GitHub data. And the first thing we did here is creating the GitHub analysis class, like a preliminary class to preprocess the GitHub data and prepare it for further analysis. Then we created an init function which instantiates automatically anytime an object is called, and it has an input called data. That is, it takes in the data frame to be analyzed, like the GitHub data itself. So the next part is extract date. It takes in the date columns, which is more than one, it says, so we have to specify it as a list. So it has the date created and the last push date. That is the date the repo has been created and the date or when the push was done last. So this time we created this, we implemented this using the algorithm below to get the necessary components from our data frame, yes. So we extracted the day, month, year, and the day name. And this automatically returns a data frame with additional date-related components. So this is the part, the GitHub looks to be very much cleaner compared to the Twitter data or to the Reddit data. So we had to go into visualization pretty quick. The data frame here gets initialized to extract what has been implemented in the GitHub analysis class. And then we have our data frame ready for analysis. This part, we are trying to choose the kind of asset to implement, the kind of asset to perform visualization on, and then they are being called here. For our GitHub data, we have choice data, we have AlgoFi data, and social data. All right, so this part is where we are trying to stripe out all trailing repository names. For ChoiceCoin, we striped out ChoiceCoin on /. For AlgoFi.org, we stripe out AlgoFi.org/. That is the name of the GitHub account, the name of the GitHub organization account. So moving on, we dive into our visualization straight up. And this is where we use the plotline library, as mentioned earlier, to generate insights from our GitHub data using different graphical representation, same as Reddit. And this time we used plotline also. So we created our init class, which does the same function as explained before. And here is the main functionality. We have activities per date. This time, since GitHub, it has different activities. It has number of contribution, number of commits, number of stars, number of forks, number of pull requests, and number of issues. So for the pull request, it has to be met, that's the condition. And for issues, it has to be active, all right? So the GitHub activities per date function inside our GitHub visualization class, GitHub plot class, is taking in all these activities and generating the insights in rows and column format per date. That is, across the date from the first time it has been created till the last day, it will show the trend of each of these activities per repository according to the date. All right, moving on. This is where we implemented the code to perform that. We used make subplot function inside our plotline library. And then here we specified the activities we want to visualize, that is number of contributors, commits, and many more. So this part, we added each of these visuals. That is, I want my number of contribution to be a scatter plot. I want my number of commits to also be a scatter. So this is where we specified different techniques for each of those activities. And then we added them to our fig variable name. All right. So we use, yes, we reset the index, and this is just us checking the count of each activities per time. I will be going into much details as regards the code, and this is the last part where we are working on the layout, how we want it to be displayed. We set the height of our visual, we set the title of our visual, we set the grid, that is, I want it to be attractive, to have grid, yeah. And then we set the template, I want my plot to be dark. The hover, I want it to be, anytime I hover on my analysis, I want the x-axis to always show. So we did all of those things here, and then we set the title to be at the middle of the visualization, which will be seen once we get to the main plot. All right, we set the font also to 20. That is for it to be bigger than all the other tests. So here we set the x-axis, what we want to display as the x-axis name and the y-axis name. So the next function here is set activity. And this time we are trying to create time series representation of each of these activities. The last time we created, the last function I mentioned, we created a function that automatically combine all these activities to just one plot. But this time we are checking each of these activities per date or per time, each of these activities per time in different plots, in different visuals, like each of them. And this time is not just date alone. We are checking it in days, we are checking it in hour, we are checking it in weeks, and we are checking it in year. All right, so we did the same thing here, and then we specify the kind of color we want for our visual. All right, so this time, the set activity, as explained earlier, we are trying to visualize for each of those activities at a time. That is, we check the day of the week, weekday, day of the month, and day of the year. All right, so we set the color for the visualization, and after setting the colors, that is, it can randomly pick any color anytime the notebook is run. All right, so we have a function inside performing this visualization, and then we are aggregating, like, that is checking the sum of each of those activities per time, and then we set the x-axis, we set the y-axis also, and this time we set ascending as first. That is, the visualization is going to show the visualization is going to show from the top to the lowest, from the top to the bottom. All right, so not to dive too much into the code, we specify the layout of our function. That is the width of about 650, make the angle tick of about 45 for the x-axis alone. And after doing this, we set our traces. That is, I want to visualize for the last push date per day, last push date per month, and all of those things. Then we set the title. That is, irrespective of whatever is being visualized on the particular day of that entity, the particular title of that entity is displayed. Then we created a subplot of about 2 rows and 2 columns, since we are visualizing for just 4 different traces, for just 4 different date components. So we move on, we set the layout, over mode, and then we set our template to dark, or just for this analysis, and then we set our title for it to be at the center, the main title to be at the center. Then we specify the date, which is supposed to be on the x-axis, and then the count, which is supposed to be on the y-axis title. So the next function here is activities per repo. The first time we did activities per day. The second time we did per activity per day component, per date component. And this time we are checking activities per repo. That is, for Choice Coin as an asset, we check all the repos inside Choice Coin, and then we get to visualize each of those activities for each of those repos. And then same thing as the first function, we are checking valid contributions, valid commits, merge pull requests, active issues, and then it's also in row by column format. So this time we also set the color which can be picked randomly anytime the notebook is run. Then we set our function to perform the main visualization and then return the final trace, that is the final plot of containing the X and Y axis of our visualization. And this time, something interesting here is anytime a repository is having more than 15 repos, we get to show the visualization, the plots in horizontal formats, because horizontal plots tends to accommodate more entities, tends to accommodate more data values. And then anytime the thing is less than 15, we use the vertical approach. And then we set it here, orientation equals horizontal, orientation equals vertical. And then we set the color, that is the color showing item. And then we have our item here, which is picked randomly from our color set dictionary. So we move down to the layout, we specify the layout, and then these are the things we want to visualize: number of bits, number of stars, number of forks, to issues and pull requests. So this time we set the title of the visualization, and then previously we did 2 rows, 2 columns, but this time it has to be 3 rows, 2 columns, because the number of entities we are visualizing is like 6 and not 4. So we did this and we set the layout. We set the layout here, and then also the title, the main title, to be at the center. And then X mode here is showing us unified. And then we get to see why this one is unified and not just X alone when we view the design, like the plot. So right now we are considering Choice Coin as a case study to check the number of activities per activity per repo. All right, to check that of repo, we specify choice data. That is, this is the data we want to analyze. And I'm trying to analyze for choice coin and not for ArgoFi. All right. So this time we activate the activities per repo function of the repo of the GitHub plots class. And this time we can see very interactive anytime you hover on the plot. That is, as we can see here, the last part showing voting, like the voting repo as the most commits. And then we can see here the bottom, we have, what's the name of this repo now? We have the tokenomics and virtual repo being the least repository with commits, with big commits, all right? And then we can check the number of stars, the count of stars per repo too. When we check this part, github.io is seen as the repository with the most star, And we can see irrespective, the y-axis showing the repository name varies depending on the one which is the highest or the one which is the least. Yeah. And then we have the last part of our stars being ASAList repository having about just zero number of stars. So moving down, we check for forks per repo. Forks per repo too, we can see this time github.io is still topping the list with about 2,993 number of forks. And we have Veta also with the least number of forks. We check the number of contributions to voting repo as the most contribution for ChoiceCoin. And then Veta repo, the same time having the least number of contributors for ChoiceCoin. And then we check the pull request and also for issues. We can see some of the repositories, they don't have pull requests at all. And also they don't have issues. But we can see voting repository is also topping the list with the highest number of issues, and also voting this time is topping the list with the highest number of pull requests. Also, so we move down to activities per date. This time we are checking each of those activities per date from like November 1, the time the data was scraped, to like date April, which is like the previous month. And then we can see a number of contributors, number of commits, we can see them varying. And this is like scatter plots with lines. And at different edge, we can see the over. So we did this also for the date, or for the activities per date. And we can get to over on the chart and see how the trends is different per time. So the next part, we can see this time, or according to the function, we are accessing set activities, which is taking each entity, like each activity at a time. And then this time we are seeing ChoiceCoin number of contributors. Looking at the chart, 0, yeah, from 0 to like 70, which is on the 30th day of the week. And for the month, we can see, Wednesday is seen to be having up to like 92, like the time people signed up as contributors, and Wednesday seem to be topping. And we can see here also for contributors per month and then contributors per year. It was the least in 2021 and then the highest in 2022. So we check number of commits, also same design, different color. Yep, number of commits per days of the week. And we can see here the 12th day of the week is seen to be having highest commits. And then I talked about over having X and X unified. For over having X, this is just over having X. That is, anytime you click on a point on your chart, it shows just the X axis alone. And then for over unified, I would like to scroll to the top. This is where over unified is implemented. And we can see this is not just showing the x-axis alone. The trace is being done across the x-axis and across the y-axis. So that's the difference. All right, so we move on to the number of commits, same thing as number of contributors, time within highest number of commits, and also time with the highest number of forks per date, which is very important. And yes, same trend, we can go over the plot and get to see how the trend varies. We did it for the number of stars as well, showing them in per day, per month, per year, and also for pull request. All right. Also for issues, which is the last one showing here. And then we did it across all the assets in our data. For ChoiceCoin, the next thing is for ArgoFi, which you can over on the charts and see the trend. And this time I talked about even the other time I talked about even asset is having more than 15 repository to be in horizontal mode, and if the thing is less than 15 to be in vertical mode. So this is where that particular algorithm is implemented. We can see here AlgoFi is having less number of repository compared to ChoiceCoin. So the plot is shown in horizontal format for the insight to be properly communicated. All right, we can over on them and see the vary over time. Thank you very much. I would like to end the recording here.